going to do here is we're going to go through a couple of sections of, this is actually content from the SEC560 class. We're going to go through some of this. I'll actually show you one of the lab exercises here as well. Now, we typically go through this a little bit slower in class, given the timing here. I am going to have to move really quickly. So just a heads up, if you're like, man, that was a fire hose, don't worry. In real life, whatever that means these days, right? We go a little bit slower. So we're going to try to give you a quick survey here of a couple of things related to passwords. The password attacks, whether it be password guessing, password cracking, it's a lot. A lot of organizations are relying on passwords. It's just simply the predominant form of authentication these days, whether we like it or not. Yes, we are moving to some of the automation without question, or sorry, automation, multi-factor as well as passwordless. That's where I was going with the automation. We are moving to some of that, but it's still out there internally. I mean, there are still many services, even if you have the multi-factor enabled, that are simply just not going to work with multi-factor, or there might be ways to bypass it. So we'll talk through a little bit about some of the password style attacks. One of the predominant ones we see these days, now my, there we go. I was like, why is my screen not changing? One of the big ones we see these days is something called credential stuffing. What is this? Well, if you're not familiar with it, just think about that last time you logged into some other random third-party site, right? And I mean third-party as in like not your work account. Now, hopefully you use a different password on your work account than you do on, let's say, something like LinkedIn. And I'm not trying to pick on LinkedIn here, but it is a recent real world scenario where not too terribly long ago, LinkedIn was breached. And the password hashes, they were properly hashing passwords, but the password hashes for users were compromised. Bad guys took those passwords, cracked them, got the real passwords, and then used those passwords and the associated email address to log into other places. And the bad guys are doing exactly this. Especially if you're using your work account. This is the biggest risk account to your work related to this. We see time and time again, because, and I say this being a pen tester, I do pen test, I see the pen test from my folks. See it time and time again where someone will reuse those credentials on a third-party site and then use the same credential on the inside. Terrible idea, by the way. Don't want to do that. Ideally, use something like a password manager. And we can talk a little bit more about that as well. What we see is there are plenty of credential databases out there, tons of them. So when these password hashes or the real passwords are compromised, they're many times published online in some way, shape, or form. It might be on Pastebin. It might be on the dark web, whatever that means these days, right? So here's an example where I use a tool called Dhashed. Dhashed, I think it's about $170 US, somewhere around there. Signed up, paid him the money, and we can do a quick search. Now, I just picked on sans.org here. I would do Red Siege, but we don't have any credentials that are compromised yet, especially those that have been cracked. I'm not saying that we're perfect. I'm not saying we're better than anybody else. I'm just saying my company hasn't happened yet. Fingers crossed. Sans much older organization, been around much longer, more times for those third parties to be breached. So here's an example here. Now, this is actually an old password of mine. Now, this was not actually, I don't even think I have a sans.org email address. I'm replacing the names of the innocent, even though it's still sort of public. In fact, let me show you another cool trick here. This is kind of fun. So this Dhashed, by the way, a paid service. Okay, you pay for it. There's APIs for it. And unfortunately, there was another free one. Let me see if I can find the pen. I don't know if I can find the pen here. Is that the pen? It looks like a traffic cone. There was a free site here, skyla.so, or however you pronounce that, .sh. Unfortunately, it is no longer. Site went down, haven't seen it come back up. The web page says it's coming back, haven't seen it come back. There was another one, the PwnDB, once again free, but you get exactly what you pay for. It went down maybe 6 weeks ago, maybe a little bit longer, and I haven't yet seen it come up. So the only real good resources that I see for like a corporate are something like this, Dehashed, Have I Been Pwned? There's a few others in there as well. A little cool trick here. Let me see if I can swap my screen just momentarily. Whoops. Discard. So let me show you something here real quick. Let me pull my screen here. So I don't know about you, but you know, I've got some of those friends that you know, I really don't need enemies. We could give each other a lot of crap. So I got a couple of friends. We were watching the college football championships. This was like a few years ago, and we're watching the game, and my friend Casey, every time I see him, he's like, "Hey Tim, have you been on the dark web?" Casey, no, I haven't been on the dark web, Casey. Do you use Thor to get there? Now he knows it's not called Thor. He knows it's called Tor, but I can't not correct him. It just bothers me. Like I have to correct him. I'm like, Casey, it's called Tor. He's like, I know. All right, whatever. So anyways, we're watching this football game. They're giving me they're razzing me a little bit of it as friends do. And one of the guys happens to say that, hey, I just end up using the same password everywhere, but it's secure. I'm like, all right, my turn. Let's dance, boys. So I go to my email, I get Brent, get his email address, and I type it in to this little handy dandy tool. Let me show you this quickly, handy dandy tool. So if you haven't used Telegram, Telegram is like, it's like Signal, it's like WhatsApp. It's supposed to be more secure, but I can say /Q, put in an email address here. Now this is more for just messing around. This is not something I would say is ready for an enterprise for pen tests. But what I can do here is give it a /Q and it'll query its database. Now I don't think its database is very good, which is why I don't think this is, you know, enterprise ready. This isn't something that's ready for your organization, but it's fun for, you know, messing with folks. And as you can see here, I did a quick query for my Gmail account, and I've got a password here of Exodus01. Exodus was a handle I went by in the 90s, 01 because whatever, right? And if you look at that, you can probably guess some of the other passwords I probably used, like a 02. If it's a secure password, add an exclamation point to the end. So anyways, I pull this up for Brent, and I get the information. Okay. So we're talking, and I sort of forget the password these days, and but I remember the sort of the basics. And again, we're watching college football, big college football fan. So I lean over to him. I'm like, hey Brent, you a big fan of Alabama football? He's like, well, of course I am. Okay. Hey Brent, does the number 34 mean anything special to you? Yeah. Hey Brent, if you had to pick a favorite special character, would you say it would be the exclamation point? And he's like, hey, wait a second. Did you just tell me my password? No, just some simple questions. Has nothing to do with the dark web or Thor. So, you know, good times there, kind of fun and entertaining, but you can see that how effective some of these things can be here. Whoops, wrong deck here. Let me restart this one. So great stuff here, right? Lots of great resources. So that if we're doing these sort of password attacks here, we've got two different ways to do this, right? I need to get the guesses. I need to get good password guesses. We'll come back to that in a little bit in a second here. But we've got, for online attacks, I've got password guessing and password spraying. I sort of break these down into sort of two sort of like 90 degrees off from each other. So like a password spray would be a single username with a list of passwords. And a password spray is the same thing, but like turned 90 degrees. A single password and a list of users, right? So now, of course, when we're doing this kind of guessing, we need a good dictionary. Now, the dictionary we're going to use here is going to be dependent on the type of attack we're doing. We're going to talk in a little bit here about password cracking. With password cracking, we can go super fast. There's no such thing as lockout. So very, very fast, no lockouts. With password guessing, we have to be careful. And we have to be careful that we don't lock out accounts. So if we're doing password guessing, we need a short list of guesses. Well, we just saw a way to get that from breached information, breached credentials. Another way is to generate a really simple list. My favorite way, and a way that's way more effective than it should be, is using sort of people and auditors against the organization. So what do I mean by that? Well, if you think about the typical organization, and if you get the chat here, we'll see if somebody wants to type in here. How long is a password good for? In most organizations, according to the auditor, how often, and I'm picking the auditors here for some unknown reason, how often are we supposed to rotate those passwords? Looking here at the chat here, see if anyone's got the answer. I see 6 months. That's a little bit longer than what I typically see. I'll just tell you, one of the things I commonly see is 90 days. Yeah, spot on, Jason. 90 days. I see 90 days coming through here like crazy now. 90 days. Very common. You know why? Well, I don't know if you know this, but when Moses came from the down from the mountain, he had a third tab. Oh, wait, wrong story. Oh, Einstein, after he did E equals MC squared, he derived, wait. No, it's a made up number, right? Going back to the 80s, whenever they set this policy or whenever it was, right? It's like Stu and Bill are talking like, hey, how long should we do it? I don't know. Quarter sound good? Quarter it is. And it just became this sort of lore that you pick 90 days. Why? I have no idea. I mean, if you look at the time that bad guys are inside of organizations, it's longer than 90 days on average, according to the Verizon breach report. I mean, the only reason that it's really getting shorter is because they're letting us know because of ransomware. Never during a pen test have I been sitting there thinking, you know what, I'm completely screwed now. Someone changed their password randomly. It just simply doesn't happen. And because we had this 90-day policy, users try to think of ways to remember their passwords. And one of the common things in life that changes every 90 days is the weather. So they can look outside right now and be like, hey, it's a beautiful spring, lovely spring. Capital S, lowercase pring, right? I've got uppercase, lowercase, but I need a number. Also, I can't repeat passwords. So I've got a spring this year, and ideally, there's a spring next year. So what do they use? This season and year, right? And after spring comes, summer, then fall or autumn. It's like twice as hard there, right? Anyway, I see this time and time again. And I don't need everybody. As an attacker, I don't need everyone to use this scheme. I need some of them to use this scheme, right? Some of them, one of them realistically, because it gets us access. Now we can email from the inside. Now we have access to internal data. Other great ones are like the organization name followed by numbers. Spot on, Jason, in the chat there. Literally the word password followed by a number. Many organizations, I've seen this, their HR gives a default password of welcome one, and it's your first day at work. You're like super nervous. Like pick a new password, like welcome two. And they just keep incrementing and incrementing and incrementing, right? Now, if we're generating a list, one of the things we want to do is select a list that matches the policy, the password policy inside the organization. Windows password policy is going to require 3 of 4 cases. The 4 cases are uppercase, lowercase, numbers, and special characters. Remember, 3 of the 4, default policy. So we can take our list, use something like PW Inspector to get a list here that is going to be compliant with the policy, because there's no need to guess a password. That's just simply not going to work here. Again, one of the things we have to be very careful of is lockouts. Lockouts are going to be a big deal here. We need to be very, very careful. What does that mean? Well, there's a couple of different pieces here related to a lockout policy. We've got the threshold. How many bad passwords before the lockout happens? Makes sense. When a lockout happens, how long is the lockout duration? Does it automatically clear after 5 minutes, 30 minutes, an hour, a day? Never. What's the observation window? There's some nuances here. Again, for the sake of time, we don't have the time to discuss it right here. But you have to be very careful here, because you don't want to cause any sort of a lockout. And the reason it gets a lot more complicated is because of what's called the fine-grained password policy. So it used to be, back when I started hacking, and before that, back when I was in IT as well, there was a single password policy for the entire domain. One, that's it. And since then, we've gotten the fine-grained password policy, which allows the C-levels to have a different policy than IT, to have a different policy than service accounts. So what we need to do ideally is find the strictest, the tightest password policy and do some testing against that, the lockout policy specifically. So for example, if the C-levels lockout for 30 or lockout after 5 tries, observation window is 30 minutes, IT observation window might be hourly, and a service account might be every couple of hours would be their observation window. If we do password guessing, we have to be aware of that. The only tool I know of that will do a password spray, remember, single password, multiple users, and be aware of those, is Domain Password Spray, written by Bo Bullock. So really, really useful tool. Plenty of other useful tools here for some of our password guessing. Hydra, similar tool called Medusa, although Medusa doesn't seem like it has been updated in quite some time. Encrack, Predator, Curb, Brute, different Metasploit modules. There's a ton of them out here. Realistically, the only difference between most of these tools is what protocols do they support, and a few other small features, but realistically, most of them are the same. In class, we take a look at Hydra, a very standard tool inside this industry, inside of a pen testing, offensive operations, if you will. If I want to specify a list of targets, I can say -M, give it the targets, and then the type of service. Now, if I want to give it a single user, I use a lowercase l. If I use a list of users, an uppercase L with a file name. Similarly, with passwords, lowercase p, one password, uppercase P, a big list of passwords. I also, if I've got credentials, let's say it's breached credentials, right? From outside compromises. Maybe it's from my phishing campaign, or credentials that we have compromised throughout the test here. We can put those :delimited in a file and then use exactly like Steve's password with Steve's username, and exactly Susan's password with Susan's username. There's no reason to mix Steven's password with Susan's username. That doesn't necessarily make sense. So here's some examples here. This very first example, we're going to use a single username of root and a list of passwords to attack SSH on a non-standard port. Next option here, we're going to give it a list of users with the password of password1. This is more of our password spray. Let's say this isn't quite the ideal tool for it, but we could definitely use it here. I want to try JSoik here. It's my cousin's initials, actually, or name. And try the specific user here, or sorry, password for JSoik across a number of Windows hosts to see if JSoik has access. And we could try, again, those credentials that we found to figure out where those credentials may be valid. There's a little bit better tools for that. We talk about that in a little bit different part of the course here. Now, if you're targeting a Windows domain, one of the things we have to do here is specify the domain. We do this by specifying the -M, which is an additional option for the module, hence the M. And I'm going to specify, in this case, Hyboxy. That's the domain we actually use in SEC560. You do need the curly braces. This isn't a put stuff here. It's literally, those are the curly braces. All right. Let's spend a little time now talking about some password cracking. That was password guessing. I'm going to go through really quickly here because we're tight on time. Some of the password cracking that we cover in class, and I want to show you part of a lab exercise as well. So John the Ripper, fantastic tool. Now, realistically, I know a lot of pen testers, I don't know, they sort of look down at John a little bit. Realistically, Hashcat is the tool these days. That said, its syntax, it's a little funky. It's a little difficult to get the syntax correct with Hashcat, especially at the top of your head. John is just easy. It just works. It recognizes the different hash type. Very, very easy to run and use. So what I'll typically do is, while I'm setting up Hashcat, I'll run John the Ripper and just use it that way. When we use John, it can run in a couple of different ways. One is the single crack. It'll use the login and other account information as a password guess. So for example, it might try Tim. It might try my name spelled backwards, Mitt. That part goes very quick. We've got a word list. Give it a big word list, a big dictionary, run through that word list. We talked a little bit about dictionaries a little bit earlier. We've got the incremental, a brute force here. This worked well when we had landman passwords, and these days they're a little bit less common, still exist, especially in domains that have been around for a while. You can actually write your own. Frankly, I've never seen anybody do that. So it's funny that Jay Soik, I literally got a text message from that Soik. I wonder if he's like watching the video. He does our Red Seed shirts, by the way. So freaked me out. I'm like, what the heck? How did you hear me call your name? As we run John, by the way, it's going to keep track of passwords that we have cracked. Be careful, because if you run John again with the same list and it has cracked one of those passwords before, it won't show you the password here. Right? And we'll demo this here in a little bit. Typically, we spend a little bit more time discussing that, but again, we got a lot to cover here in just this simple hour. When we're running, you can look at the status, hit a key here, and it'll show you how many guesses, what percentage complete, the number of attempts, cracks, combinations, whatever per second. And it will show you some of the passwords that it's trying as well. And we can benchmark this. Now, I'm not going to do the benchmark in the lab exercise, basically for the sake of time. But you'll see here, and especially if you've got a high-powered cracking rig, you should see significant differences between John and Hashcat. Definitely if you've got things like additional GPUs. Okay. As I mentioned, Hashcat largely supplanted John the Ripper. It's got some extra capabilities and extra features that just make it a little bit easier for some of the cracking, gives us a little bit more flexibility. Again, just ends up being preferred related to some of the hardware cracking here as well. So let me skip ahead to that. So Hashcat, fantastic tool available, hashcat.net. Runs Windows, Linux, Mac. Realistically, we run it on bare bones Linux to make this thing as fast as possible. In the lab exercise, and in fact in the demo here, you'll see in just a moment, we're going to run it in the Linux VM. Not ideal. It's a VM on a laptop, right? Realistically, ideally, we'd like to have a cracking rig of some kind. Now, I mentioned John is really easy to use. Hashcat, not so much. So with John, we can say like -- format equals NT. Well, that's the NT hash. With Hashcat, and I forget the number, I always get it backwards, we have to use a -M and then specify the number. If I remember it correctly, the NT hash is 1000 and the LM is 3000. I always get those backwards. I can never quite remember. But if I remember correctly, the NT is 3, whatever. I have to look it up every single time. Similar to John, when we're running, if we crack a password, it will store that hash and password that have been cracked in its pot file. A little bit different name here. If we want to see the results, we can say -- show to see the output, very similar to what we did with John. And if our system were to overheat, crash, reboot, power off, it saves state every so often, and we can use -- restore to pick up where you left off. Now, both John and Hashcat have additional mangling rules. What the rules will do is take an example, a password guess, and change it. Might flip it. Might add a number. Add a 1, then a 2, 3, all the way up to 9, then 1 0, 1 1, 1 2, and then skip to 2 1 2 2. Add other weird random characters. I mean, not random. There's actually very prescribed list there on ways to modify that. And it might take a single guess and convert it into hundreds or thousands of other password guesses, depending on what the password might be. We can also, now the rules, I really don't write rules. It's too complicated to me. Maybe I'm not smart enough. Masking I do. So with our attack mode, what we're typically doing here is we're using the straight attack. We're doing this straight attack here, meaning just use the words in the dictionary. We also have these options 6 and 7. The 6 will add our mask to the end. The 7 will add the mask to the beginning. What can we add? We can add uppercase, lowercase, numbers, special. So the L, lower, U, upper, S, special, N, numbers, or A, all. Try all of the characters and build our own mask. What does that look like? Here's an example where we're going to use the -A6, which is going to add it to the end. Question mark D, question mark D, question mark D, question mark D. I think I got the right number of Ds there. It's going to add the numbers 0000 through 9999. Now, it's not going to do 0 through 9999. If you wanted to do that, then you'd use the -- increment. If we want to put the numbers, in this case, at the beginning, we'd say -A7, question mark D, question mark D, question mark D, question mark D. I'm counting off screen. Or we might see like, a number and a special. So question mark D, question mark S. The example we have here is 2 digits and it's 1 special character added to the end. It gives you a lot more flexibility without having to write your own mangling rules. Of course, going to go run much slower in that way. If we hit the status here, a lot more output on the status with Hashcat than we have with John. You're going to see the temperature, estimated time to completion, a lot of other information here from Hashcat. Now, regardless of what you're doing, if cracking, guessing, cracking with John, cracking with Hashcat, one of the things that we don't do is when we write a report, we don't include the real passwords in the report. Because realistically, the problem isn't that the user used spring or summer 2022, right? The problem is they're using this season and year. So we try to describe what's the broader problem. Oh, it's poor password selection based on the season and year. Not that this specific password is wrong. And we word it that way because I don't want someone to say, oh, we'll just ban summer 2022. Okay, great. But what happens in 90 days or more, right? Take a step back. Are they using a password that's a derivative of the word password? That's the problem, right? Not P@SSWORD. It's a derivative of a very common word that we use for passwords, literally the word password. Okay, so I know I went through that relatively quickly. Again, for the sake of time, we spent a little bit more time in class covering this. Let me pull up my Linux VM here, and I'm going to walk you through part of a lab exercise. Give me just a second to move this over here. Obligatory stuff on the screen. There we go. So what I've got here is this is our Linux Slingshot VM that we use inside the class. And by the way, I can see questions along the way if they come up You can ask along the way, save them for the end. Either way works with me. But what we've got in here is what's called our electronic workbook. I'm going to pull this up here just to show you it really briefly. Get my screen just set up here. All right. So for example, the lab exercise we're going to go through right here is on day 3, the cracking with John the Ripper. And it gives us, search capability. We can look for our lab. So really neat stuff. You can also, if you get a really long command, you can copy and paste. Like here's a little quick cleanup. Now don't actually copy. I mean, sometimes it's useful, but I prefer that people type than copy and paste because it helps you solidify the stuff in your mind. You get a little bit better practice with that. Okay. All righty here. So let's go through the first part of this lab exercise. We got plenty of time left here. Perfect. Sorry, I'm doing some stuff off screen here. You can't see here. Trying to save and maximize space here. One of the first things you do in the lab exercise, we do a little bit of benchmarking to see how fast the systems are. And you'll see, for example, like the LM password hash is going to crack literally, I think it's hundreds of thousands of times faster than some of the Linux password hashes. And we discuss in the class why that is. And the reason is there's salting and there's additional rounds of hashing with Linux passwords versus Windows passwords. For the sake of time here, we're just going to take a look at some of these passwords. So if I cat some passwords here taken from a Windows host, whoops, wrong one. So these are taken from a Windows host here. So we see our password hashes. Username, this is the RID, the ID, we can think it. Here's the LM password hash. You'll notice it's the same for most of these users. It's going to be null value here. And then the NT hash. Now we don't have time right now to break those down, but Windows is going to store passwords in 2 formats. Since Microsoft Vista, Windows no longer stores the LM password hash. That said, you might still see it on a domain controller for a very old account. Okay, so let's run a very quick crack here. So we'll say John here on my password hashes. And you saw there, we looked up above, a lot of this AAD3, right? This is the null LM hash, hence when we come down here. You'll notice here, when we run John, I didn't tell it what kind of hashes there were. In fact, it says, hey, just a heads up, we detected the LM hash type, but I also think it's NT, right? And if we look up here, we've got the LM here on the left, the NT here on the right. So it's just giving us a heads up, like, hey, here's what I'm doing by default, keeping it easy, keeping it real. But if you want to change things, here's the command. And there's also the CL, which allows us to use different hardware accelerations. I'm in a VN, not as good. Okay. If we come down a little bit further here, we can see that we have cracked the password hash for vberry. This is LM password hash. One of the nuances, the issues with the LM password hash is it actually converts every password to uppercase and then splits it into 2 7-character passwords. So there's not an account vberry1 and vberry2. It's vberry, but it's the first half and the second half. Okay. Shane, I do see your question here. I'm going to come back to that in just a few minutes here. Okay. Let's try this again. Let's try format NT. Format equals NT. And we can see here that it's going to use the default list right here. Right. These NT password hashes are going to be a little bit harder to crack because it's the full password, the full case. Yeah, I forgot I was gonna say something else. All right. You remember here, we only cracked one of these up here with the LM password hash, but the LM password hash uppercase split into 2. So what I'm going to do here is say, hey, for that password, what I want to do is I want to crack the NT, but I want you to take the LM password hash and use that as a guess for NT. And remember here, the LM is converted to uppercase. So all it's going to do is put those two pieces together, convert it back to uppercase. And we can see we end up cracking this random 14 character password quite easily because LM is so bad. Now, realistically here, I'm not going to get a lot done with just the default list. The default list isn't very good. It's not a modern list. So I'm going to say -- word list, opt passwords, RockU. So RockU password list here. RockU was a website, had millions, it was 11 million, 35 million, I forget what it was, millions of users with passwords stored in clear text. So this was compromised, published online. We can use this list then as guesses, because if one user has used these passwords, maybe another user has used these passwords as well. To answer Shane's questions here, are word lists such as the top 10 million still valid today? What I see, Shane, these days is for password cracking, what people will do is basically get every single password that they can possibly get and use those. So for example, there's a collections database file, whatever you want to call it. It is a bunch of breaches put together into one giant list and just let that run for days, weeks. Much bigger than necessarily the 10 million here, right? All right, so that was the NT. Again, all of these passwords just happen to be in our password list. We haven't done anything fancy here, no masking, no special rules. If we take a look now at, these are Linux password hashes. These are going to be SHA-512. Okay, so it's going to crack much, much slower. Multiple rounds, thousands of rounds of hashing per password here. Very, very significantly slower here. You see I get 3,700 password attempts per question, or sorry, per second. These are attempts per second, barely into the thousands. Whereas with the LM and the NT, we're going to get hundreds of millions. You can get significantly faster if you're not running it in a VM on a laptop too, right? We can run this once again, -- word list. Little tab completion here. We'll let this run. And again, this is going to take a while here. I'm going to hit Control-C just for the sake of time, because this is only, thousands. We saw when I ran through RockU with the NT, it took 2 seconds. If I let this run through the Linux password hashes using SHA-512, it's going to take significantly longer. Now with Hashcat -- help. We saw with John, just simply saying -- format, and then a name that's easy to remember. Well, with Hashcat, we have to give it a number. So we'll see here. Let me change this up. I don't want to go through the whole list. I'm going to say grep LM. And we can see the LM password is 3,000, which I think I was right before. 3,000, not the easiest to remember. NT or NTLM, same thing, is 1,000. MD5 crypt is 500. That one I remember because it's got a 5 in it. But what we're going to do here is a little bit of password cracking with Hashcat. So I'm just going to, for the sake of speed, I'm going to copy and paste. So I'm going to say, we'll scroll back up, let it run while it's going. A workload of 3. How much of my system resources should you take? The max is 4. I still want it to be usable, so I'm going to say 3. The attack mode is just the straight word list presented over here. The mode here, this is going to be the NT hash, and then these are the password hashes. It's still initializing the backend runtime, whatever that means. So give it a second here. We should see in just a few moments. Let me resize this. Is we should start seeing it crack a few of the passwords. I was hoping while I talked it finished. There we go. So we got Warrior07. And if I give it more time, it's going to crack some more of those passwords. There we go. We just happen to have the same passwords on Windows and Linux, but you saw how much slower here it is with the Linux passwords than the Windows ones. If we take a quick look at one of the rules, so here is one of the rules files, best 64 rules. The colon, if I remember correctly, doesn't do anything. That reverses it. This changes the case. I don't remember what this does. It's going to add the numbers 0 through 9 to the password. Here it's going to add 0, 0, 0, 1, 0, 2, then 1, 1, 1, 2, 1, 3, then 2, 1, 2, 2, 2, 3, then 69, 7, 7. So it just grabs some of the common numbers to add to our passwords here. Okay, so what I'm going to do is I'm going to do that same attack again, but this time I'm going to say -R user local share doc hashcat rules best 64. What? Oh, no, I want to head that. That's the wrong command, isn't it? And for some reason, they didn't initialize much faster this time. But what it's going to do here is take every single password and then modify it a number of times. Okay, for the sake of time here, I would like to get one of them. Oh, we got two of them. Okay, cool. So let me quit that. So we found two passwords. So what we did here is it grabbed a password from RockU, ended up adding some digits to the end and getting additional passwords. Kind of neat. And I can see the output using a syntax like this, username and password that we've cracked so far with Hashcat. Again, for the sake of time, I'm not going to go through the details of that command. In a class, we would. We can do some additional masking. So I'm going to get this started and we'll scroll up and look at what's happening. So I'm going to do with this particular attack. This is a masking attack. So what we're going to do is add to the end. What are we adding to the end? We're going to add 2 digits. So we're taking English words and we're going to add 2 numbers to the end of that. And what we'll find here, what we should find here, get out of there, stupid tooltip, is a couple of words like homosyntogenesis, whatever that means, and the number 42. All right, that's kind of cool, right? We can do the same thing here. Let's try to do this again, but let's say, well, instead of a digit, let's do a special character, because a lot of times people will take a word, add a number, and then a special character. Found a couple more passwords there. Antitoxin 7 bang, Coronut 7 hash pound, whatever you want to call this. We can do this with a couple of other password lists here as well, RockU and a couple of others. Okay. And then what we can do is as we crack those lists, and let me just build the full list right here just for the sake of time, is if I cat opt passwords, whoops. Here is the full list of passwords that we would have cracked with the full time on each of these. What I want to do now is I want to use a rule, and again, let this run in the background, is I'm taking the passwords that we have already cracked and mangling those to see if maybe 2 users use similar passwords. And then we'll find it. This is going to go actually quite slow. But once it runs here, what we should see relatively quickly, actually, you know what? Let me do, and there's SEC560, you're right. What we should see here in just a minute, we're going to see somebody else used a Metallica password. So we had a Metallica password, 6 ampersand. What we should see here once this starts running, go, stop initializing, just run, go. Yeah, it's copying stuff to memory, but I don't understand why if I rerun the thing, it sometimes takes longer and sometimes shorter. I don't know, whatever. But we'll see some additional passwords here. So one of the things you want to do when you're doing your password cracking is take previous guesses and feed them back in and keep feeding those back in to see if they can give you some additional guesses. Sort of a longer discussion point is and I'll tell you where we land on this in a little bit, is if you're doing a test for organization B, do you save the passwords afterwards? Originally, like my mind was no. Once a test is done, you throw those away. But realistically, a password without the account is meaningless, right? Just like I can get a list of every single social security number. Now, having the social security number without any of your information, also meaningless. So what we do, and we're very careful with it, is save the passwords from test to test to see, hey, is this a pattern people use? Honestly, did somebody move from organization A and go to organization B, and now we get credentials, things like that. And we can see here, we get Patrick now with this, 6-digit number here at the end. Cool. So that is the quick survey of SEC560, newly renamed enterprise penetration testing. 50% change, 53, I think is the exact math, between this new version of the course and what we had just less than a year ago. So lots and lots of changes. Super quick survey here of these 2 modules related to password guessing, password cracking. Do we have any questions before we wrap up here? Any questions? Chuck them into the chat here. Happy to answer any sort of questions.
I'm just looking at that now, seeing if we have any. And also, I just dropped the course page in there, which has been newly updated from what Tim was speaking about. So take a look at the syllabus and see if you have any questions, or also just to see all the fun changes with enterprise penetration testing now.
Yeah, and if you have questions, hit me up on Twitter. I'm not the fastest to respond, but and of course the SANS folks will be more than happy to answer questions as well.
Yeah, and I was going to drop, that's
go.
Tim's Twitter handle right there. So if you're not already following him, definitely please do. Some hilarious sports and travel references, occasional pants joke here and there, as well as some cool tips and tricks. All right, well, it doesn't look like we have any questions coming in. So Tim, I appreciate the time very much. Thank you for putting this together. You know, we love to have demos that are from these courses, just also to put this content out for the community. For all of you listening in, we very much appreciate your time as well. Thank you for joining us. If you would like to see more webcasts that we have on demand or coming up scheduled in the future, you can of course look at sans.org/webcasts. And Tim, I don't know if you have any parting words. If you do, go ahead.
Yeah, thank you all for attending. And I'll be doing some more of these. We'll have some other great pieces of this course, other rando content here as well. But yeah, check us out. Happy to chat with you all. Say hi in the real world. And yes, go Packers, as you can see from right there.
All right. Thank you all very much. We appreciate the time. The recording of this webcast will be available in your SANS account, and also future webcasts that Tim does with us as well. All you have to do is register for them, and you'll have them, the recordings available for as long as they're archived. We appreciate it. Take care and have a great day.
Thanks, everyone. Have a good one.